Now, let us come to the actual figures. I had told you some quantitative figures depending on the different steel applications. I have told you at the very beginning that how a quality of steel is defined. It is basically conformance to application requirements. Different steel products are basically meant for different applications. I have also told you that total oxygen is a measure of oxide cleanliness. It is a very important requirement. Now, in normal grades of steel, which are not very stringent, if the total oxygen is less than 30 ppm, we usually think that the steel is okay, that means the quality will be relatively okay, this will pass the test for the normal applications of steel. So, we tell this is relatively okay quality of steel. We allow the steel to pass for the next level of processing, but if the level of total oxygen is more than 40 ppm, what do? We downgrade the steel. That means we use the steel not for these normal applications, but for some inferior applications, as I had told earlier. So, a decision is taken based on total oxygen, which indicates the cleanliness level of oxide cleanliness level of steel. Now, let us go through or look into what are the cleanliness requirements of various steel products depending on the applications. So, I have talked about the steel product here, the minimum residual content, that means the element oxygen, nitrogen, and what is the size of the NMI, maximum size. Here also we have talked about the maximum level which is tolerable, beyond that it is not tolerable. So, let us come to an important steel product, line pipe steel. You know, steel, plates of steel which is used for making big pipes for processing of, transportation of gas or liquid. So, here only 30 ppm of total oxygen is tolerated, not beyond that. Nitrogen again 30 ppm, not beyond that. Inclusion size maximum 100 micron, beyond that it is not tolerated. So, these are the requirements for line pipe steel. I will come to the other requirements of line pipe steel in the next slide, possibly about the sulfur, phosphorus and other elements, but here I have just mentioned what are the oxygen, nitrogen requirements and what are the size of the NMI. Now, another important important product is deep drawn sheet, which is used for making many applications like car body, like some filters, many important applications are there. So, what is the requirement? You see, oxygen requirement is still stringent, 25 ppm, nitrogen is 30 ppm, maximum NMI size is 100 micron. Now, let us go to heavy plate. Heavy plate is important in the process industries, in bridges, in different other applications. Here you see what is the oxygen requirement. This is more stringent, 20 ppm only, nitrogen 30 ppm. The cluster of inclusions is important here, 100 micron, but single inclusion it is only 20 micron. So, that means here the stringent requirements are there for heavy plates. Let us go to another important product, drawn and ironed can. Nowadays you see a lot of steel cans are being used for as container for say soft drinks, say beer cans, you find a lot of cans. So, these are very thin sheets which is with very stringent applications. What is the total oxygen requirement? 20 ppm, that means oxide cleanliness has to be very high. Nitrogen 30 ppm, only 20 micron is allowed for the NMI. Why finer size? Because as you are going to very thin dimension in the product, whether it is thin sheet or thin wire, even slightly larger inclusion will show up on the surface during processing, during rolling. So, we have to be very careful of the size of inclusions in these grades of steels. So, drawn and ironed can, total oxygen less than 20 ppm, nitrogen 30 ppm max, inclusion size 20 micron max. where, as I was telling you, again another important product, steel product, total oxygen 30 ppm, nitrogen somewhat higher is allowed 60 ppm, inclusion size is 20 micron. Now let us come to another very important product of stringent requirement, tire cord. You know, whatever tires we are producing, rubber tires, they are very thin wire which are known as tire cord, which tries to hold the rubber tire. So these has very stringent requirements. Look at the total oxygen, hardly 15 ppm is allowed, nitrogen 40 ppm, 15 micron is the maximum size of NMI. So as we are going to more and more stringent applications, residual contents are becoming more and more stringent, maximum limits are still lower, so we have to be more careful. Ball bearing steel, you look at the oxygen requirement, total oxygen 10 ppm, this is total oxygen, that means dissolved as well as oxygen as oxides, it is just 10 ppm, inclusion size 15 micron. So these instances will indicate, will throw light on how for different applications different residual contents are restricted, the size of the inclusions are restricted. So quality is getting quantified here, it is no longer qualitative. We have to tell while we are producing a line pipe steel that we cannot go to a level of total oxygen more than 30 ppm, it is not acceptable. Nitrogen more than 30 ppm, not acceptable. Inclusion size more than 100 micron, not acceptable. So these are the levels of quality which are nowadays demanded from the steel. Similar is the case like say ball bearing or tire cord. These two are extremely stringent steels with products with extremely stringent requirements. Look at their levels I have mentioned earlier. So while we are producing these grades, we have to be very, very careful. As I was telling you about the disposition of cast steel. Suppose we have cast slab where we have got an inclusion level or a residual content of oxygen, total oxygen as say 30 ppm, and we want to produce a heavy plate from that. Can we do that? No, but maybe we can do a line pipe steel from that, because line pipe steel the limit is 30 ppm is allowed, but heavy plate only 20 ppm is allowed. That means when you are producing the slab, at that stage we have to decide whether the slab we have produced can be processed for heavy plate or cannot be processed. If the level of oxygen is more than 20, but it is say around 25 or 28 or even 29, that means slightly less than 30, maybe we can process it for line pipe, provided nitrogen also is within this range. But the total oxygen indicates that if it is more than 20, it cannot be processed for heavy plate. It cannot be processed for drawn and iron can, because here also the requirement is 20 ppm. When you are producing tire cord or ball bearing steel, from billets, these are produced from cast billets, we should know what is the level of total oxygen and then decide whether these billets can be processed to these qualities of stringent requirements. Otherwise, maybe we have to suppose total oxygen is 30 ppm or 35 ppm. What do we do? Maybe we can process it for building materials, which is not of such stringent requirements. We can prepare it for other construction grades, which are not of so high requirement, such high requirement. So what I am again repeating, depending on the requirements, we have to identify for which grade the steel can be processed. Now let us go to some other requirements. I have talked about requirements for oxygen, nitrogen, inclusion size. Now let us talk about what is the stringency on sulfur, phosphorus, hydrogen in this particular grades of steel. And I am only talking of steels for stringent applications. I am not talking of simple applications, steels of simple applications, where possibly you can be more tolerant, residuals can be tolerated to a higher extent, slightly larger inclusions can be tolerated, but not for the steels for stringent applications. Let us get into certain applications like line pipe steel. I had discussed earlier for oxygen and nitrogen and inclusion size. You look at the stringency, sulfur has to be less than 0.005, phosphorus has to be less than 0.10, hydrogen has to be less than 1.5 ppm. So, these are the levels of stringency in line pipe steel for sulfur, phosphorus and hydrogen. So, that means when you are making steel, not only we should do proper desulfurization, we should reduce phosphorus, we should do good amount of degassing so that our hydrogen is less than 1.5 ppm, and before the steel is cast or at the that stage, whatever analysis we are taking, that should ensure that we are within these ranges. Then only that steel can be further processed for line pipe steel. Deep drawn sheet, sulfur again has to be less than 0.005, phosphorus less than 0.15, that means slightly more phosphorus can be tolerated. Line pipe steel, phosphorus cannot be tolerated very high, because this phosphorus and sulfur will create central segregation and create a lot of problem, quality problem. Hydrogen, there may be hydrogen crack if hydrogen is more than 1.5 ppm. So, we have to be very careful on these counts. Higher grades of CRNO. What is CRNO? Cold rolled non-oriented steel, which is used as magnetic materials for motors and generators, or even some transformers. Cold rolled non-oriented steel, these have more amount of silicon. Depending on what are the applications, silicon can be 1%, 1.5%, 2%, 2.5, up to 3% silicon. So, here also sulfur restriction is there, less than 0.1, phosphorus less than 0.15. So, what I am trying to harp upon is, depending on the application requirements, not only oxygen, nitrogen, inclusion size, there are restrictions on sulfur, restrictions on phosphorus, restriction on hydrogen. So, while we are doing evaluation, as I have mentioned, this sulfur, phosphorus, hydrogen, oxygen, this can be analyzed relatively fast, and from this analysis we have to make a decision on the quality of steel at the cast stage itself, whether this cast slab or bloom or billet should be processed further for that particular quality, because every quality has quantitative stringent requirements. These are all quantitative. So, we should know at the cast stage itself what are the level of this quality factors, what are the level of total oxygen, nitrogen, sulfur, phosphorus, hydrogen, depending on the particular steel application, and take a decision whether this can be processed. We have to take actions beforehand, and finally, when you are making the analysis, we should conform that analysis will conform to the application requirements. That means a specific quality requirements. So, today what we have covered? We have covered how evaluation of inclusion is done, how sulfur, phosphorus they are analyzed as a part of the routine analysis, how total and oxygen and nitrogen can be analyzed from small machine samples. This is normally not done for routine analysis, but should be done for making good quality of steel, because we should have an idea of what is the level of oxide cleanness, what is the level of nitrogen, because all these elements are quantitatively specified in today's high level of or stringent requirements in the specific grades of steel. So, we have to be very careful during preparation and during evaluation. I have also mentioned these micro inclusions, macro inclusions, how they can be evaluated, but these are time taking. So, okay, these are good for post-mortem analysis, but does not really help for making a quick decision on the quality of steel, quick decision on the disposition of the cast steel for further processing. I have also mentioned that elemental analysis under SEM for the with the attachment of WDX or EDX help us in identifying what are the elements present, and from there we can come to a conclusion of what are the constituents present, like what are the types of inclusions. These are all post-mortem analysis. This takes time. So, once a quality issue has been identified, once a quality aberration has led to some problem in the final product, so as a post-mortem analysis we can do this evaluation to identify what went wrong. Then I have talked about the 2D information on sample size, how it can be converted to 3D distribution by this simple relationship. Then I have talked about what are the important issues, like we are identifying shape, content, size distribution. These are all okay, but these are all time taking, time consuming. In contrast, analysis of sulfur, phosphorus and total oxygen and nitrogen, even hydrogen, they are relatively fast in steel. So, using this information we can take a quick decision on the quality level in the cast steel itself and take a disposition decision, whether that cast slab should be processed for which type of quality. Then I have talked about the different levels of residual contents requirements, different level of NMI size. These are all for different applications: line pipe, deep drawn, heavy plate, drawn and iron can, wear, and I mentioned the tire cord and ball bearing. These are the two applications with the most stringent requirements. You look at their total oxygen requirements: ball bearing 10 ppm total oxygen, 15 micron maximum NMI size. So, these are the stringent requirements. Line pipe steel, sulfur, phosphorus, all have to be very, very low, less than 0.05 sulfur, less than 0.10 phosphorus, hydrogen less than 1.5 ppm. Similarly, deep drawn grade and higher grades of CRNO, stringency on sulfur and phosphorus. One thing I must mention here, hydrogen analysis, because hydrogen is atomic number is very low, the lowest. So, the diffusivity is also very fast because the size of the atoms are very small. So, hydrogen, if you keep even at normal temperature, whatever hydrogen is there in steel will try to diffuse out. So, for hydrogen analysis, what is important is you put the sample under liquid nitrogen and then take it to the hydrogen analyzer. So, that will give us more realistic analysis. We should get a realistic analysis only when the hydrogen sample, the sample with hydrogen is kept on the liquid nitrogen before it is put to the hydrogen analyzer. Thank you very much. I have tried to cover the different issues which impair quality, what are their quantitative levels for different steel applications, how we have to be very careful about them.